Monitoring tools out there, open source tools, Nagios and Zabbix. They're both well-known tools, but there are also subscription-based tools out there. The MongoDB Cloud Manager is available, and that's from MongoDB themselves. It's part of the MongoOps framework. Then there's Vivid Cortex. Vivid Cortex allows you to install an agent on MongoDB servers and then send off the metrics to their implementation. And also ClusterControl, which is doing more than just monitoring. It's a full stack deployment system, monitoring system, maintenance system. For Nagios, we have the Nagios MongoDB plugin. And this plugin performs basically all the basic important checks. So like replication lag, log time of the records, and log time of the schemas. And this is important because then you know how often this happens. And that's also similar to the MySQL logs that happen in InnoDB. Index miss ratio, which is important because MongoDB also supports primary and secondary indexes. And if you have some secondary indexes that are not used or not that useful, you might actually want to drop them. We have the MongoDB Zabbix monitoring plugin that allows you to use Zabbix for alerting. It installs basically all the necessary metrics and more. It also keeps track of the entries in the op log and warn you if this goes over a certain threshold. And it has many pre-canned triggers. And for the people not familiar with Zabbix, pre-canned triggers basically means a lot of predefined alerts. If you move on from the monitoring side, we go into trending. So why do we need trends? Like I said earlier, with trends, we are able to plot them based upon the metrics that we collect. We can find problems before they actually arise, and that's called preemptive problem management. So we are able to do something about the problem that may come in the near future. And also, there are some really good trending tools out there that allow you to do very fine-grained sampling of the metrics. And the finer sampling, the better. The more data points, the better. Keep in mind that just similar to MySQL replication lag, that can go up and down all of a sudden from 0 seconds to 10 seconds within only a few seconds that are happening because you're basically running a long-running query. Similar in MongoDB, you might actually have a spike in the metrics that you're collecting. So the more data points, the better it gets. If we look at what metrics we need to store, it's all quite similar to MySQL. We need to store metrics of CPU, memory, I/O capacity, disk space. You may want to do some benchmarking up front, that you know actually how much is the I/O capacity, and then set, for instance, a threshold on that in your graphs. And it also gives you the ability to look at, for instance, the used I/O at the moment in the graphs, and see how close you are to the I/O capacity of your machine. And if you're nearing that, you may want to do something evasive like scaling out, or maybe migrate or shard your MongoDB cluster. You need to do also replication monitoring. You need to get like the replication status, replication lag, but also oplog size and the usage of the oplog. And then you can plot trends and can see whenever something is going or is almost going wrong. Then there are some trending solutions out there. StatsD Grafana is the most often used at the moment. Cacti and Zabbix, a lot of people are using them as well, next to StatsD Grafana. And there are the subscription-based MongoDB Cloud Manager again, Vivid Cortex and ClusterControl. For Cacti, Percona made some really nice MongoDB monitoring templates, and those templates have become available quite shortly after Percona acquired Tokutech. Tokutech is the creator of TokuDB, and Percona is nowadays shipping their own version of MongoDB, including Tokutech. And hence they made the monitoring templates for Nagios, for Cacti in a similar way as they created the monitoring templates for MySQL. They have all the necessary graphs that you need, showing, for instance, the background flushes or the index operations that happen. Now, having a monitoring system and try to do evasive monitoring thanks to threading, if things start going wrong, you better have backups, and that's also why we included backups in this webinar. So MongoDB has two types of backups: logical backups, where you basically make a dump of your data, and physical backups, where you create a file system copy of your data or copy files. That's depending per implementation. For the logical backups, we have mongodump, we have MongoDB Backup, and MongoB, and I'll dive into each and every one of them individually. So mongodump is basically like MySQL dump, and it has it dumps the data in the BSON file format, and the BSON file format is basically binary JSON format. It's a tool that gets shipped with MongoDB, just like MySQL is being MySQL dump is being shipped with MySQL. It works great, but if you want to do something fancy, you need to add some wrapping scripts around it and apply some logic to that. It's a really simplistic tool that only allows you to do a couple of basic operations, just like MySQL dump. We have MongoDB Backup, which also makes a very good logical backup. It's a Node.js solution, and that's a really good thing because Node.js also can run as a web server. So you have both a CLI component where you can create a backup on the command line, but you also have an API component, and the API component can be reached via HTTP. And that's especially useful if you're using some sort of orchestration system or chat ops system in your company, and then you can tell this application to make a backup or a snapshot of your database. In this case, it can also stream backups, so that's a nice way of streaming data from your MongoDB server into, let's say, the machine of a developer, for instance. Then we have MongoB. MongoB is a Python-based command line tool, and it allows you to specify another MongoDB instance or itself, or a BZ target, and that allows you to either make a file copy on disk or a logical dump on disk, or copy, for instance, data between collections. You can use it to, for instance, populate an existing collection into a new schema. Those are the things you can do with it. It also allows you to create incremental backups. You can copy the data from, let's say, this date till that date, and it allows you to do rate limiting on the copy. So if your network isn't that performant and you are afraid that it will impact performance, or maybe your MongoDB server is IO bound and you want to ensure that it's not going to read a lot of data from disk in a very fast pace, you can rate limit it. Physical backups, similar to MySQL, you have LVM, ZFS, XFS, and EBS to your disposal. For MongoDB, you need to specify Mongo freeze, and that freezes MongoDB for only a couple of seconds, that you are able to make the consistent snapshot. Last backup tool is Strata. Strata is a tool that backs up MongoRocks, and MongoRocks is the Facebook storage engine for MongoDB. They open sourced that, and it can only be backed up by using Strata. The backups are done on a file level, so it's similar to InnoDB or Extra Backup in this case, where it makes a copy of your data and then at the end copies the op log, and you can apply then the remaining operations. It makes you also able to query your backups offline, so you are able to create a copy of your data into a separate folder, and then you can apply queries to that instead of starting up, for instance, a new MongoDB client. And this is really useful if you have a MongoDB cluster. You just simply make a backup of it and then ship that to a file server, and then you query that and ship the data of your MongoDB server offline to, for instance, your data warehouse. And it's really nice way and non-intrusive way to do that. It also supports incremental backups in a way that similar to, let's say, the way it's done in InnoDB. So you provide similar to within InnoDB the LSN, the last modified page within, in this case, MongoRocks, and then it will make a copy from that point onwards. Then we have backup management. Backup management in the form of Zamanda is having support for MongoDB, where this plugin only supports mongodump and Filesystem snapshots. If you have other backup managers, you might want to look into customized scripts to implement that. We were not able to find anything beyond Zamanda that can handle backups in general and then have a plugin for MongoDB. Then we have the ClusterControl live demo. ClusterControl is our own orchestration system. As I explained earlier, it can do more than just monitoring. We use it for deploying, monitoring, managing, and scaling not only MongoDB, but also MySQL, NDB cluster, Postgres, and Galera cluster. And the nice feature of this is that it actually gives you a transparent interface between let's say MongoDB and MySQL, and you don't see a lot of differences between the two. So let's go to the ClusterControl interface. You can see that there are two clusters defined here. We have a MySQL replication cluster and we have a MongoDB replica set. Both of them have this very same basic features, like overview with the dashboards, the nodes, the query monitor, performance, backup, management of the nodes, and the logs of the nodes. Also, in a similar way, we can, as we have, for instance, a MySQL replicated setup, we could define a new node by adding a new MongoDB replica set. Adding a new MongoDB replica set allows us to choose either Percona or MongoDB as a flavor. We simply have to provide a host name, a couple of usernames, and click on deploy. And this will start to deploy a new node, which is considered to be a new cluster. You can use that as a standalone node, but you can also add nodes to the replica set. And that is basically the scaling part of ClusterControl. You can easily add a node to an existing cluster. So if we would select the replica set that we want to add the node to, we simply provide the host name, click on add node, and a new node will be added. And this is a nice way of scaling your system.